All right, let's peek under the hood of, well, everything. We're going to talk about the invisible world that powers our lives. We're going to pull back the curtain on the 4 fundamental components that make everything from your phone to your car work. And you know what? It's not magic. It's actually just a few simple, really elegant rules.
I mean, have you ever really stopped to think about it? How does a wireless charger just send power through the air? Or how can a computer chip that's smaller than your fingernail have more raw power than the giant room-sized computers that first took us to the moon? It seems impossible, right? But the answers are surprisingly simple, and it all starts right here. You look at all the incredible complexity of modern technology, every app, every single photo, every connection you make, and you think it has to be built on thousands of complicated parts. But it's not. It's not even hundreds. It's just 4. That's it. 4 fundamental building blocks, the absolute foundation of all electronics. Honestly, the best way to think about these things is like Lego bricks, you know? Individually, they're super simple. Each one has a very specific job to do. But when you start snapping them together, well, that's when you could build literally anything, from a little blinking light all the way to the most powerful AI on the planet. Okay, so before we meet our 4 little Lego bricks, we need to get the rules of the world they live in. And the easiest way, by far, is the classic water analogy. Just picture electricity as water flowing through a set of pipes. A circuit? That's just a complete closed loop so the water can flow around and around. Now voltage? Think of that as the water pressure pushing everything along. And current? That's just how much water is actually flowing. If you can get that simple picture in your head, you've got the key to understanding everything else.
All right, let's meet our first brick. This is the resistor, and its name pretty much gives the whole game away. It resists. This is the humble but absolutely essential flow controller for the entire world of electronics.
So if electricity is water in a pipe, a resistor is like putting a kink in that pipe, or maybe squeezing it so it gets really narrow. See, it doesn't stop the water completely, it just makes it a lot harder for it to get through. It slows it down, it reduces the flow. Now you might be asking, why on earth would I want to slow things down? Well, the number one reason is just protection. A tiny little LED, for example, can't handle the full blast of current from a battery. It would just pop like an old-school flashbulb. So you put a resistor in front of it to choke that flow down to a nice, safe level. They can also divide voltage. You can use them to create a precise lower pressure point in the circuit for more sensitive parts. And, as we're about to see, they team up with our next component to create timers.
Okay, moving on to our second component. This is the capacitor. A good way to think of it is like a tiny, personal, ultra-fast rechargeable battery for a circuit.
Let's go back to our water analogy. A capacitor is basically a water tower. It takes a little while to fill it up, right? It's storing all that water, all that potential energy. But then when you open the gates at the bottom, whoosh, it can unleash all of that water in one massive, instant rush. A capacitor does the exact same thing, but with electrical charge. It stores it up and then can dump it all in a split second. The perfect real-world example is a camera flash. Your camera's little battery could never provide that huge burst of light on its own. So what it does is it slowly trickles energy into a capacitor, charging it up, and then, flash, the capacitor dumps all of its stored energy in an instant to light up the whole room. Capacitors are also great at being like tiny water reservoirs that smooth out any lumps or ripples in a power supply, making sure your sensitive gadgets get a perfectly steady stream of energy. Our third component brings in a really crucial idea: control over the direction of the flow. So meet the diode. It is the official one-way street of the electronics world. You know, this analogy is a perfect one-to-one match. A diode is a one-way check valve, just like in plumbing. Water can push through it one way, no problem. But if that water tries to flow backward, the valve just slams shut. A diode is an absolute gatekeeper. It enforces a strict one-way traffic law for electricity. And this one-way street trick is incredibly powerful. The power coming out of your wall outlet, that's AC, and it flows back and forth. But your phone needs a steady one-way flow. That's DC. Diodes are the things that basically chop off the backward half of that flow. It's the first critical step inside any power adapter you own. They also work as simple, foolproof protection. If you plug a battery in backward, the diode just says, nope, and blocks the current. And hey, you know every little LED? That stands for light-emitting diode. It's just a special one-way gate that happens to glow when electricity is flowing through it the right way. And that brings us to our fourth and final pillar. And let me be clear, if there is one single invention that enabled the entire digital revolution, it is this one right here, the transistor. It's an amplifier and a switch all in one. So for our last analogy,
Imagine a massive fire hose, just blasting out water with incredible pressure. But the handle that controls this huge flow is so small and sensitive that you could turn it on and off with just a light tap from your pinky finger. That's a transistor. A tiny little whisper of an electrical signal on its control pin can instantly open or close the floodgates for a much larger flow of electricity.
This amazing level of control gives it two superpowers. First, it can amplify things. A tiny signal from a microphone can control a bigger current to power a huge speaker. But the second superpower, this is the aha moment that changed the world. It can be a perfect switch. That tiny little control signal can turn the main flow completely on or completely off. And that simple on or off state, that's it. That is the 1 and the 0 that makes up the language of every single computer on Earth.
And when I say it's the language of every computer, I mean it at a scale that is it's almost impossible to wrap your head around. A single modern processor, like the one in your phone or laptop, doesn't have a few thousand of these switches. It has billions. Billions of microscopic switches, each one flipping on and off billions of times every single second.
And the process itself is just beautiful in its simplicity. A tiny signal shows up at the control gate. That's your finger capping the faucet handle. The gate opens. The big current is allowed to flow through. Take that tiny signal away, and the gate slams shut. The flow stops. On, off. 1, 0.
So there you have it. Those are our 4 Lego bricks. Individually, they're pretty clever, right? But the real genius, the true architecture of our digital world, that all comes from how they work together.
This right here is the ultimate cheat sheet. The resistor is the kink in the pipe, controlling the flow. The capacitor is the water tower, storing and releasing charge in a burst. The diode is the one-way valve, making sure traffic only goes in one direction. And the transistor? That's the faucet. It's the amplifier and the all-important switch. Pretty much everything you own with a power button comes back to these 4 jobs.
And here's the most empowering part of all this. You don't need an engineering degree to get the basics of our world. If you can really wrap your head around these 4 components and just remember their simple water analogies, you have genuinely unlocked the fundamental principles behind almost every piece of tech you use every day. So the next time you pick up your phone, don't just see some incomprehensible black box. See it for what it really is. A tiny, bustling city with billions of faucets and gates and water towers, all working together in perfect harmony. And the best part is, you now understand the language of this city. So the only question left is, what could you build with it?